So I've been asked to talk about ocean resilience, but I had to throw in the word coastal because I am more of a coastal ecosystems person than an ocean. And I think science has played a role in identifying what we've done to the ocean. And I think science will provide a way to understand what can we do to reverse some of these trends. And then that's very different from what will we do with our knowledge from the science. I'm going to talk about the Nearshore Ocean. As I mentioned, it's an area of high primary and secondary production. A high proportion of the world's fisheries production comes from this area. It's where people live. It's where people see their coastlines degrading. It's where coastal economies bring a huge amount of money into all the nations of the world. It's an area of transportation. This is where goods move into and out of our economy through the ports. It's something that people can see, as opposed to the deeper ocean, which I consider just as important. But as we've seen, some of the timescales in the deeper ocean are very different from the timescales that we're going to see in the Nearshore Ocean. So what have we done? We have warmed our atmosphere, notice the red. We have warmed our water, notice the yellow. We have disappearing deltas. This one used to be much bigger. Sea level rise is happening, and this whole landform used to be bigger. We have a Corynea brevis bloom here, this red. We have a cyanobacteria bloom right here that shut down drinking water supplies in Toledo, Ohio for several days a couple of years ago. And for the West Coast people, you can't see it because pseudonychia doesn't usually give you as much of a color change, but this is what's killing the sea lions on the Pacific coast right now. And you can't see it underneath that here. We've got bleached corals and all kinds of other things happening. No single one of these alterations is independent from the other, just as ocean acidification, deoxygenation, warmer temperatures, they're all tied together. They're all tied together in the coastal zone as well, just as in the open ocean. Sea level rise. This is, I love the new format for EOS and EOS Buzz because they give you all these really great articles that you can then put into a talk with a good graphic. This is South Beach, Miami. This is a flooding event. Miami spent a lot of money in 2014 to develop a system to pump this water out, this flood water or storm runoff water out and into canals and into Biscayne Bay. Well, now they're finding out that these waters that are seeping back in or coming back in are full of E. coli. 4 times the magnitude of what's acceptable to the EPA. So we have science that will tell us about resilience. Now we need to use our science to figure out what can we do about all these E. coli that are coming in to South Beach. And a lot of it's stormwater runoff. Our deltas are disappearing. 500 million people, half a billion, live in deltas, and they are rapidly disappearing. Loss of sediments due to damming, sea level rise, subsidence from taking out groundwater, or in the case of Louisiana, often oil and gas exploration as well. And the Mississippi River itself has 40,000 dams that are 20 feet or higher on its length and its major tributaries. So human activity is making a lot of changes. We know, as I said, warming, deoxygenation, acidification One of the, we heard about some of the work at Marine Lab earlier about adapting corals and refarming and putting them back out. NPR is where I get my science information. So there's a recent story about raising higher temperature resistant corals and then actually putting them back out into the environment. And I personally have seen these coral farms underwater and how well they can take over an area. So science is again giving us a way to try to provide some of the resiliency for the ocean. Something that I studied, low oxygen, as a result of eutrophication, which is usually resulting from high nutrient input from the watershed into the oceans. This can lead to some of the harmful algal blooms and hypoxia or dead zones around the world. And these are increasing over time, and it's not because more people are studying them. They're increasing over time because of changes in human use of the landscape and population and other things. And I have to tell Andrea that my time scales are 200 years. So warming temperatures, bleaching, we've heard about coral bleaching. Coral reefs, of course, are areas of high biodiversity and very important ecosystem services. So how have we done this? The course of change has been mostly in the last 200 years or 300 years. The Industrial Revolution, the high increase in human population, the very enlarged carbon footprint, the very enlarged nitrogen footprint, and if Jim Elsa were here, I would say the increased phosphorus footprint. And all of these are important. And they have changed dramatically because of agricultural policy, and in my opinion also for energy policies. We grow corn not to feed the world. We grow corn to make ethanol, to feed hogs, to feed chickens. And most of the corn that's grown in the U.S. is not used within the U.S. And this push for ethanol has also caused, I think, destructive ways of using our landscape. I do not use ethanol in my car if I can help it. Fortunately, I live in a part of the country that has a lot of motorboats that need non-ethanol fuel. It costs me more, but I get much better mileage, and I'm not putting as much of the pollutants into the air. And besides, it's wrecking the landscape. So, what can we do? Well, it's not horror anymore. It's a smiley face. And yes, we can do something, but you see that S is a dollar. So it's going to take dollars, but it also needs to take political and social will. So we don't want to wait to respond to the next crisis. One of the next crises is going to be the collapse of the agricultural way of doing business the way we've been doing it for the last 100 years. We need to have more sustainable agriculture. We have to have cover crops. We have to have crops with deeper roots. We have to have crops that still produce a lot of grains for biofuels that do not ruin the environment. And with this increased biodiversity and agricultural development, we will also have to use less pesticides and fewer fertilizers. It's a win all around. But the fear in those who are studying sustainable agriculture is that it will require a collapse of the agricultural economy to get to that point. There are a lot of people working right now to get to that point without the collapse. There are ways to mitigate sea level rise. As I say, be prepared to dike and move people, pets, and plants. The Pointe-a-Chin Native American community at the end of an old distributary of the Mississippi River has now gotten the money to move their full community out of their community that is no longer always out of water, but mostly underwater. So they're going to move them to Bray Louisiana, you don't know where that is, but if you consider sea level rise over the next 80 years, they may be having trouble in Gray, Louisiana as well. One of the good things that can be done, besides farm and field policy, is, I was going to say the green economy until I heard about all the metals that we need to make solar panels and wind farms, but I do think it's a better way to go than continued use of fossil fuel. River management. There are river management ways of releasing sediment. The Huanghe, the Yellow River in China, has gone through some recent sediment releases because that delta, which is at one time was a huge growing delta, is no longer there, and it's starting to affect the infrastructure for their oil and gas production and exploration. It takes a crisis to do something, but we can do something. A lot of the channelizations of rivers can be reversed. And so there's lots of things that science can tell us what we have done over 200 years to change the ecology of our coastal waters. But I think education, of which many of us are involved, and which ocean leadership, of course, is involved, is the one way to get to the younger people around the globe so that they can start thinking about their future, because many of us at my age apparently didn't pay enough attention to the future of our children and our grandchildren, but again, we didn't at that time have the science to inform us about what we were doing wrong. So there are opportunities through education to make a difference. And if you want some social and political solutions, our next two speakers, David Cash and Scott Rader, can give you those solutions, because I only have a few of them to share with you. Thank you.